Alright, so now let's proceed to the binary search. The binary search algorithm using Typescript. Before that, let us understand what is binary search. So this is the efficient approach for searching. So this works on the sorted arrays by repeatedly dividing the search interval in half. Okay, so I know the definition may be a bit difficult for you, so let me tell you. Okay. Let's say you have an array that is sorted 1, 2, 4, 6, 8, 11, 15 like this, and now you want to search for, let's say, 4. Okay, you want to search for 4. What you do is that you select a middle element. Here let's say 6. Okay, 6 is your middle element. Now here 6 is greater than 4, so your last element will become 6, and now you are searching from 1 to 6. Okay, like this. Now here in between 1 to 6, let's say the middle element is 2. Okay, so 2 is less than 4, so first element is equals to 2. Now between 2 and 6, the middle one is 4. You have found it and you return. How many steps? Only 3. Whereas, I understand in linear search also you would be having the 3 steps, 1 and 2 and 3. But what if you had to search 11? Okay, so in linear search you will go 1, 2, 3, 4, 5, 6. 6 steps. But in binary search, what you would do is that first you go to 6 is less than 11. So 6 is the first element. Now 6 and 15. Mid element is 8. 8 is still less than 11. Now 8, 15, 11. In 3 steps you will be able to find it. That is how the binary search algorithm works. Okay. But remember guys, point to be noted, this will always work on sorted arrays. Okay, so your arrays need to be sorted so that you can use the binary search algorithm. Okay, like this. Here the time complexity in the worst case will be O of log n. O of log n, because what you are doing is you are dividing all the operations by half. Instead of doing each and every iteration, we are dividing here iterations, not operations. Every iteration is cut every time your condition is not matching. Okay, now it's time to write some code and actually implement the binary search algorithm. So what will be the steps? Let me tell you. I am telling you the steps to implement binary search so that you can try it on your own and you can see my code as well. So there will be 2 pointers. Left equals to start of array and right equals to end of the array. Okay, now calculate mid like this, left plus right by 2. Now what I will do is, if the middle matches the target, then return mid. Otherwise, if mid is less than target, left is mid plus 1. So after mid you will be starting. And if middle is greater than target, means the last index is one less than the mid. Okay, and these steps will be repeated. While left is less than equal to right, these steps will be repeated until you find the element. Or if you are not able to find, then the range becomes invalid and you return -1. So yeah, these are the steps. Now it's time to write some code and actually implement this. Can you try it on your own? Please pause the video and try. Otherwise, I am implementing this to show you. Alright. Here the space complexity also is O1 because we are not going to use anything else. Okay. Now, function binary search. Here you got an array of numbers and target. It is also a number. Now, let left equals to 0, let right equals to the last index of the array. Okay, so while left is less than or equal to right means you are still having a range. Let's calculate the mid. Middle will be max.floor, means left plus right by 2, means the indexes are, let's say, 1 and 4. 1 plus 4 is 5, so 2.5 is not an index, it will take 2. Okay, like this. Now if you reach the point, so if you have reached it, then you return that index. The mid is the index. Otherwise, if it is less than target, then left will be mid plus 1. Otherwise, right will be mid -1. What does it mean? It means that if the index, the middle index, is less than the target, means we are still behind, so we will start from next of the middle, and if it is more, then we will set the range to end one index before mid. Okay, like that, and that is how it will calculate. So examples. Now these two are the examples. You are searching for 5, you are searching for 11. Okay, but 11 will not be found, so let's search for 9, and let's search for 11. I will run this code. 4 8 minus 1. Okay, 4 8 minus 1. Now let's run this inside our debug terminal. I will be adding the breakpoints here, here, here. So left is 0 currently, right is 9, and so we calculated the mid, and here mid is 4. Okay, so yeah, look how early it calculated, because in linear search 1 2 3 4 5 5 steps here, at the very first time only you were able to find it. Look at how fast it is. Now again you are finding 9, mid is not equals to target. Okay, now the mid index for this array, so array mid means at the fourth index is 5 and target is 9, so yeah, left will be mid plus 1, and now left is 5. Look at that. and again we are not able to find it again. Now left is 8 and we are able to find it because mid is 8 means value is 9 and you are able to find it. Alright guys, this is how the binary search algorithm works in TypeScript.